Alright, this is the second video of two where I'm discussing how to factor trinomials using the AC method. So I'd like you to look at number 10 and see if you can figure out exactly what's different about this problem. Well, hopefully what you're seeing is this is not an x squared and then an x and then a constant. So now we need to kind of dig down a little deeper and think about this. Factoring out, or I should say factoring by using the AC method is just one of three methods we've learned so far. And the first one we discussed was factoring out a GCF, and that's what we can do here first. So notice all of these have at least one factor of x. The first term has three factors of x, the second has two, and the last one has one. They all have at least one factor in common, one factor of x, so that is our GCF. The numbers 3, 5, and 2 don't have any common factors other than 1. So this will be x times 3x squared. That'll give us that. And what times x is a minus 5x squared? I'm going to need a minus 5x. And what times x is a minus 2x? That would be a minus 2. And so the first thing we did was factor out a GCF, but I want you to look inside the parentheses here, and that's the kind of trinomial that we should be able to factor, or at least the kind we've been factoring using the AC method. So we're going to focus on this part right here. When we're done, we're going to get two factors, two binomials that multiply to this, and we'll need to have an x out front. So we're going to end up with three factors here. So in this case, I need two numbers that multiply to negative 6 and add up to negative 5. Well, your only options are 1 and 6 and 2 and 3. Now be careful here. Sometimes students pick the wrong factors here. But if you think about it, I need these numbers to multiply to negative 6, so they have opposite signs. And since they add to a negative, I need the bigger numbers negative. And so the one that works is 1 plus negative 6. So when you multiply, you do get negative 6, and when you add, you get negative 5. Sometimes students will use like negative 2 and negative 3, but that doesn't multiply to positive 6. So you've got to be careful here. So all we're doing at this point is focusing on this trinomial. It's 3x squared plus x minus 6x minus 2. So we can factor out an x. It's x times 3x plus 1. And here we're expecting to get a factor of 3x plus 1. And notice 3x times a minus 2 would give you that negative 6x. And negative 2 times 1 does give you negative 2, so that does work. We've got two terms with a common factor of 3x plus 1. And if you cross those out, you could see the other factor is going to be x minus 2. Now don't forget, we had this x out front, and that's part of our answer. So I want you to notice, if I wanted to check this, I would start by foiling 3x plus 1 times x minus 2, and I would get 3x squared minus 5x minus 2. And then I would multiply by x, and I'd get back to where I started. So we'd have to do two multiplications to get back to where we started. All right, so at this point, you may feel comfortable that you can do numbers 11, 12, and 13. All of them are going to require you to factor out a GCF first, and then whatever's inside the parentheses, you'll be able to factor using the AC method. And then I'd encourage you to watch the video and make sure you did it right. All right, so I'm going to go ahead and do these. On this one here, for 6, 20, and 16, my GCF is just going to be 2. So it'll be 2 times 3x squared minus 10x plus 8. So just like in the last problem, the part in the parentheses is a trinomial that I might be able to factor using the AC method. I need two numbers that multiply to 24 and add to -10. So the ones that are going to work are -4 and -6. When you multiply, you do get 24. -4 plus -6 is -10. So let's split our b term. We get 3x squared minus 4x minus 6x plus 8. And we'll factor out an x in the first two terms. So it'll be x times 3x minus 4. So when I factor the second two terms, I need to figure out what times 3x minus 4 gives me that. Looks like a -2. Notice -2 times 3x is -6x, and -2 times -4 is +8. So that does work. And so for these two terms, we have a common factor of 3x minus 4. 3x minus 4 times x minus 2. And then don't forget, you had factored out a 2. So your three factors are 2 times 3x minus 4 times x minus 2. All right, let's go ahead and move on to number 12. So on number 12, it looks like you should have factored out a 3. 15, 39, and 18 are all divisible by 3. That's the largest factor. It'll be 3 times 5x squared plus 13x minus 6. Now, sometimes students struggle with finding the correct greatest common factor. You know that inside the parentheses, there should be no common factors. If there are, then you've made a mistake. There's a bigger number that works. All right, so now let's factor the trinomial inside the parentheses. I need two numbers that multiply to -30 that add to 13. And you might be careful here, or you need to be careful here. 3 and 10 look like they might work, but they don't actually work. It's going to be 2 and 15. Because they need to be opposite signs and add up to 13. So if I make my 2 negative, that'll work. -2 times 15 is -30. And -2 plus 15 is +13. Notice if I use 3 and 10, 3 plus 10 is 13, but the problem is that doesn't multiply to -30. I can't get the 3 and the 10 to work. So let's go ahead and split our b term. We get 5x squared minus 2x plus 15x minus 6. And again, I'd remind you, the minus 2x and the 15x, it doesn't matter which one goes first. So here I can factor out an x. I get x times 5x minus 2. And so I'm expecting a 5x minus 2 when I factor 15x minus 6. And of course 3 times 5x would be 15x, so I need a plus 3 in here. Notice 3 times -2 does give me -6. And so my two terms have a common factor of 5x minus 2. The other factor is going to be x plus 3. And then don't forget to bring that 3 down. And that's your other factor. And again, if you wanted to check your work, you could FOIL these two binomials and then multiply what you get by 3. So when you multiply these, you're going to get what's in the parentheses here, and then you would distribute the 3 and you'd be back to where you started. So we know that once we factor, if we multiply everything out, we should have what we started with. All right, so on the last one here, it looks like our GCF is going to be 4n. 4n times 2n squared gives me 8n cubed. I'm going to need a minus 5n next. and a plus 3. All right, so again, we're going to factor what's inside the parentheses. I need two numbers that multiply to 6 that add to negative 5. And it's going to be 1 and 6, and the 6 is negative. Wait a second. Nope, that's not going to work. My other option is 2 and 3. See, I can't change one of these because they have to both be positive or both be negative in order to multiply to a positive 6. So I can't get that to work and add up to negative 5. But what I can do is use 2 and 3, make them both negative. Notice negative 2 plus negative 3 does give you the negative 5. And so you can see how what we did here is similar to what we did up in number 10, where we had 1 and negative 6 as our factors. Here it's negative 2 and negative 3. You really got to be careful that your signs are correct and that the numbers you choose work. Notice here, negative 2 times negative 3 is 6, and negative 2 plus negative 3 is negative 5. So let's go ahead and split our b term. We get 2n squared minus 2n minus 3n plus 3. We can factor out a 2n in the first two terms. We get 2n times n minus 1. So when we factor these other two terms, we're going to expect an n minus 1. And you can see to get the minus 3 in there, I need to multiply n by minus 3. So we're going to get negative 3 times n, or minus 3n, and negative 3 times negative 1, that's a positive 3. So we end up with n minus 1 times 2n minus 3. And again, don't forget you had a 4n that we factored out to start. And so our final answer is 4n times the quantity n minus 1 times the quantity 2n minus 3. And that's going to be it for this video.